Hi, I'm Chris Knight, and today I'll be walking you through a project that I made for my friend Pete. It is a virtual chainsaw blade for his cosplay Steampunk Chainsaw. It's made using largely off-the-shelf parts, one custom part which is a 3D case that I designed and printed just to protect the electronics. All of the parts have links in the description for this video of where to buy them, with the exception of the 3D printed case, where you can download the model that you can print your own. So first, let's take a look at the parts that we used for this project. First up is a fairly generic 18650 battery shield. It takes two 18650s and gives me a nice constant 5 volt. Also has ports for charging the batteries. So I can put this into a self-contained project where the user never has to pull the batteries out to charge them. The brains of this piece is a Arduino Pro Micro generic clone that I picked up off TradeMe. You can get them off AliExpress, Amazon, anywhere. I'll provide a few links in the description of the video. We had some miscellaneous bits, buttons, switches, potentiometer. It allows us to set up some controls for this. A strip of APA 102 gamma-corrected addressable LEDs in a silicon sheath so that it's waterproof, with a couple of 4-pin connectors on the end. I got those from Cool Neon. I'll see if I can find a link on Amazon for you. And then when it's all assembled, it all goes into this fairly generic, boxy 3D housing that I made, and in a moment you'll get to see it all put together and running. To power this unit, we're going to need a couple of 18650 batteries. These are relatively generic ones I picked up off TradeMe. Market's flooded with these things. You can find them anywhere. Again, though, links are in the description. Very, very important when you drop these in here to get the orientation correct. If you these have no these shields, they're generic, they're cheap, they have no protection in them for the batteries being put in incorrectly, and you'll blow the charge controller on the backside. It'll just crack open. So we're going to drop these in. There we go. Now if I was putting this together to actually be used at the moment, we'd close the case up, put the screws in, have it all sealed. So now I'm going to show you what the controls do. So the first thing we're going to do is we are going to hook up the LEDs. I'm going to lay them out so you can get a kind of a view of what they're going to do here. The connector here can only go on one way. It's a keyed connector. It's got a screw on end, keeps it locked in place. Normally we'd have an O-ring here, but since this is intended to go inside of the chainsaw, I'm not really worried about it getting exposed to water. So we'll turn this on. There's a power switch here. Hit that power switch. Unfortunately, it's kind of recessed. So, it's on. We've got a red light. It's glowing. But what's up? LEDs not lit. The switch here, it's a 3-position toggle. Center position is off. Now, technically, it's not off in that the Arduino is still running code, but what it's looking for is a signal from one of 2 digital pins. And we flip the switch, and the first mode we get is an HSV rainbow that is cycling the length of the ribbon. And the knob here, we can control the speed of that. So if he wants that chainsaw to look like it's ripping, crank it up, slow it down. Now, what's this button? What is this button? So when I made this, Pete wasn't sure how many of the LEDs are going to be exposed on the blade. And so since the HSV rainbow here, the color matches from end to end, or it's a continuous loop that ends there and starts here at the other end. And so for it to look really good, we don't want to have a chunk of the color rainbow lost. So what this button does is it lets me adjust the number of pixels, number of LEDs that are exposed. So if he's got half of the strip tucked inside the chainsaw, he can turn this dial, let go of the button, and now that's the only part that's lit up. A nifty little trick here is Arduinos have a small amount of EEPROM on them. So when you let up the button and it sets the length, it writes that to the EEPROM, and when you turn it off and turn it back on again, it remembers that length. And then if he makes changes to his chainsaw, he can hold the button down again, dial it in, let go, and off it's running. So we got it dialed in. This is our length. What's the other mode do? We'll flip the switch the other direction, and he's got flaming chainsaw blade. Ooh. There's a bug in the code. You can only dial in the length of the chainsaw blade when it's in rainbow mode. Gotta fix that. Okay, I'm back. You might notice there's been a slight change in the lighting. That would be because hours have passed in the making of this video. I discovered I had a couple of bugs in the code running on the controller, and I took some time to fix that, make some improvements, create a GitHub repo for it, you know, all the fun stuff. So we're back. Okay. We still have two modes. We have the a HSV rainbow mode that gives us the rainbow blade for the Steampunk Chainsaw. We have the fire mode, and one of the things that this is doing is 2 pixels are on, 1 is off, 2 pixels are on, and then by swirling or by rotating that, it creates the illusion that it is moving in this direction. And then one of the improvements I've made is the mode for setting the length. Now works in all 3 phases. So it works when it's off, works when it's works when it's off, works when it's in rainbow mode, and it's going to work in fire mode. It looks like I had one last bit I need to fix. I'll have that fixed in just a moment. So give me a second. Do 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 do. There we go, and now it works. Okay. So length setting works in all 3 modes. That's fixed. Good to go. Okay, let me put it back together, and then I'll give you a little tour of the ports available on it. And we're back again. Okay, so the 3D housing has a couple of holes in it. Let's see what those holes do. First one, the power button. Pressing that turns it on. You can tell it's on because there's a red glow coming through the plastic. To turn it off again, press and hold the power button till the red light goes off, and it's off. I'll go ahead and turn it on. This is a marked dev port. Not sure if you can see it in the lighting. So this is where you would plug a USB micro cable if you're going to reprogram it, having made modifications to the source code. Again, linked in the description. This port here, this USB-A port, is a 5-volt power output port that will allow you to use this to power other devices at the same time. Off those two 18650 batteries. On the side here we have 2 sets of cables coming out. One is some old ATA ribbon cable, recycled out of a computer, that goes to our potentiometer and our switch for controlling the mode. And then we've got the 4-pin connector that goes to the LEDs. The red button here, this is the button that you press and hold to put it into the mode for tuning in the length that you want. And then these are the charge ports. You have a USB micro and a USB-C. Either one of those can, oops, sorry, the charge ports. USB micro, USB-C, either one of those can be plugged into USB output from your car, from your computer, and that will recharge the batteries that are built into the unit. And there you go. We have got the Steampunk Chainsaw blade in self-contained controller, or self-contained controller with internal batteries, all ready to go. And now that I've got a video that walks you through how to use it, I'm going to put it in the mail and send it off to you, Pete. Enjoy.